Okay, so a video explaining the difference between tensile stress strain graphs and compressive stress strain graphs. Now, to understand the difference between the graphs, first of all we need to understand exactly what it is that we are talking about. If we have a spring, and the original spring looks like that, so we have original length here, which we'll call L. There are two options with that spring when we come to applying a force. We can either apply a tensile force, which is a pull force, and that tensile force, there we go, will extend our spring like this, and the extension is very straightforward. The extension is given by this amount here. Or we can have a compressive force, and the compressive force here a bit, will be a push force acting this way, and the push force will extend it by, original length was here, sorry, will not extend, sorry, will compress it by this amount here, which we also call x. So what we notice here is that this dashed line here is the original length. The x just stands for a change in length. Now, if I were to plot a graph of, my pen's run out, if I were to plot a graph of f versus x for the tensile strain graph, I would see a straight line like that, and it would kind of go like that, with this being the limit of proportionality, limit of elasticity, yield point around here, and then fracture point over here. There is nothing really any different if I were to draw a compressive strain graph. Now, it may well be that the shape is slightly different for that particular spring, okay? But ultimately it looks the same. There is a region with f equals kx. The k here under compression doesn't necessarily have to be the same as the k under extension. It can have different stiffnesses. Concrete is a good example of this. Concrete is very stiff under compression, but not so much under extension. And there we go, we have exactly the same points on this graph as well. So we have our limit of proportionality, our yield, elastic limit, yield point, and failure point. Okay, so really there is no difference. Stress strain graphs exactly the same as well. The only difference is, if you wanted to, you could say this is a pull, this would be our tension, and this would be a...
Hello everyone. Today I'm gonna show about the difference between compressive force and tensile force. First, I'm gonna explain about compressive stress. Compressive stress is the opposite of tensile stress. An object experiences a compressive stress when a squeezing force is applied on the object. So, an object subjected to a compressive stress shortens. Compressive stress is also defined as the force per unit area. The compressive stress that develops when external compressive or squeezing force is applied on an object is given by stress equal to force over area. Higher the compressive force, higher the compressive stress. The video shows that force happens when I compress the vacuum hose. Next, I will explain about tensile stress. Tensile stress is a quantity associated with stretching or tensile forces. Usually, tensile stress is defined as the force per unit area. The tensile stress that develops when external stretching force is applied on an object is given by stress equal to F over A, where A is the cross-sectional area of the object. Therefore, the SI unit of measuring tensile stress is Newton meter squared, or Pascal. Higher the load of tensile force, higher the tensile stress. This time, I will pull out the vacuum hose to determine the tensile force.